My name's Scott Stewart. I'm a passive house certifier in New South Wales, and I've been a passive house consultant since 2014. Prior to that, I was in the Air Force for 20 years and flying around and doing stuff with that. And a passive house is much like an aircraft. It's a system of systems, and it really just makes sense. It's not rocket science because I used to do that. In fact, you can heat a passive house with a hairdryer. And that was a good pitch. It got me a job in Portugal doing a passive house shipping container a little while ago. But the essence of what I think the perfect passive house isn't when we can add more things into it. It's when we can't take anything else away from it and it's still a passive house. Because it can be simple, it can be really cost effective when you don't treat it as a bolt-on. It needs to be integrated, and when you do integrate it, it can be really cost effective. And we've found that we've got about 30 live projects we've got at the moment. We built our own passive house in Woolgoolga on the north coast, so we've dealt with humid climates, and it does work in humid climates. And we've done a bunch of work with Ibrahim from Marvel in Sydney. So it's a great system, it can work, and the numbers don't lie.
Hi everyone, my name is Ibrahim. I'm from Marvel Homes. My brother and I basically started Marvel in 2018. We both an engineer. He's a civil engineer and I'm a mechanical engineer. It was sort of a dream at uni time to start a construction company. Fast forward, eventually we are here. Like what Scott said, passive house doesn't have to be complex, and being an engineer, we just like to simplify everything. Keep it simple, keep it straightforward, keep it easy. To date, we've completed 5 certified passive houses and on track to finish another 5, currently in different stages. We believe that passive house is the way to health, energy efficiency, and net zero. It is not that complex. It is quite easy when designed correctly, when detailed correctly. And we strongly believe in it that it is the way forward for the industry.
So just to start the conversation off, maybe Scott, could you start off by talking us through the way in which buildings designed to the passive house standard achieve greater comfort with less demand on the energy grid?
So because passive house focuses on getting the envelope right first. In fact, the software doesn't actually let you touch any of the toys that you might see on page 2 of Renew magazine, like the hot water systems or the solar panels. We don't even look at that until we solve the envelope problem first. And when you solve the envelope problem, you ensure that the house can maintain above 20 degrees in winter. And that's not just 20 degrees during the day, that's overnight as well. So for anybody who doesn't like their kids to sleep underneath the window because it's a cold draft and they get asthma at night, then that doesn't happen in a passive house. You don't put a beanie on at night and you wake up in the morning and you're not afraid to go to the toilet because it's too cold. So it's 20 degrees, and then we aim to maintain below 25 degrees in summertime and maintaining approximately 60% relative humidity. Now, in Sydney and further north, humidity is the biggest issue, and there's nothing like walking from outside and it's 28 degrees and 80% relative humidity into a house that's 25 degrees and 60% relative humidity. Now, by being able to maintain the temperature range, and there are small excursions and it's across the whole house, so we do have to emphasise to our clients that yes, some parts of your house where you have that sensor, it might be 26 degrees, but in another part it might be 24, so okay, we're not failing here. But by maintaining that energy across the whole day, we're avoiding the massive peaks and troughs. So in New South Wales and Australia-wide, we have the big peak between 7 and 9 o'clock in the morning, and then between, say, 5 o'clock and 9 o'clock at night when people get home from work and they're putting their their 30 or 40 or 50 kilowatt air conditioning system on to cool the house down. But by maintaining that 25 degrees throughout the whole day, we avoid those peaks, which then reduces the massive reliance on the grid in those peak times.
Next bit, we're going to move on to, I guess, how we work in the passive house community to achieve collaborative procurement, and it's all well and good to say we're going to add insulation, we're going to make something airtight, we're going to add ventilation to a house, manage thermal bridges, but to make all of that happen in the context of an expensive building market, it's actually a really difficult thing to bring along. And so just wanted to talk about some of the different strategies that those of us on the panel have been employing to make things happen. And let's start off with Ibrahim. As passive house builders, your focus has been on finding ways to offer passive house at scale, and through a combination of engineering knowledge that you and your brother have share. Can you tell us about your lean passive house system?
Yeah, as a builder, essentially the bucket stops with us to make sure we meet all the design requirements, all the architectural requirements, all the passive house requirements. So my brother and I, we went back to the drawing board and be like, okay, what is it can we do to be able to actually scale this up, be able to do multiple projects at the same time, and have the guarantee that we're going to achieve the airtightness, achieve the insulation, and deliver a certified house. We looked at different materials, we looked at SIP, we worked with some of the materials. Well, essentially what came down is our contractors, our trade base. That was basically the bottleneck. The training and the skills that we have to coach, it wasn't allow us to scale. So we went back and looked, what is the principle of passive house? What is it that we try to achieve? And that's when we came up with what's called the lean passive house. And ultimately the goal of the lean passive house is we took the trades and the contractors' skills, and we're like, how do we design and what materials do we select and construction details so that way it complements their skill and complement the passive house requirements. And with the help of Scott from Lab Design, we came up with a whole design system, which we called it the lean passive house. And essentially it's a whole cycle where it looks at the design of the house, the material selection, the implementation on site, and the construction details, so that we can guarantee that we are going to hit the target, we are going to achieve an airtight, we are going to meet the insulation requirement, and ultimately deliver a healthy, energy efficient, and a certified passive house. To date, this has been meeting its deliverables. It has achieved what we expected to do. We delivered, like I said earlier, a 5 certified passive houses, and on the process to deliver another 5. And we can see that it can actually expand, where it can be multiply used at the same time to accelerate the deliverable of a certified passive house.
And I guess thinking about how you make, you've got your lean passive house system, you have your preferred methods that you want to approach the building side of things and details. How do you like to work in terms of integrating the design team for those specific projects?
As part of it, so we get a lot of clients to come through our doors with their own designs approved, and they want to build a passive house. Obviously, cost is a huge factor in this equation. And what we found is that the teams that engaged us early in the beginning of the cycle allowed us to help them deliver the project on budget, on time, and meet the requirement. So essentially, what is the lean passive house? It's a system that we allow us to give a quick feedback loop to the designers, to the architect, to the passive house designer, as well as to the client. It's easier to modify things on paper while we still can before it goes to approval in construction, than go on site and try to figure out how do we deal with this. As a builder, ultimately I have to comply with the legislation first before everything else. So I'd rather fix it at the beginning at a design when it's easy to catch, it's easy, it's cost effective, and it creates efficiencies in the operation on site, which means it's beneficial for the customer as well as quicker deliverable for the project as well as for us. And that's where the cycle of the whole system of lean passive house came from.
Scott, we've talked about operational energy on a carbon optimization, but can you please tell us a bit about how you can use the passive house planning package to optimize the material requirements of a house?
Yeah, so I guess at LAB Design we do use the PHPP extensively, but we've also got a bunch of other tools in our toolbox, because like Ibrahim said, sometimes it's not the passive house bit becomes easy, it's just the council bit that gets hard. And one of the hardest things to get around is the termite detailing, because depending on where you are in the world, no matter how hard you can convince a certifier that, hey, this slab edge insulation is really going to work, and he goes, I don't care, mate, I want to see a 75mm inspection gap around the whole house, because he's been literally bitten by a termite-ridden house before. So we do a lot of thermal bridge modelling and virtual prototyping so that we can truly lean out stuff. And it's usually by getting calls from Ibrahim, who at the start was like, oh no, we've already done this, do we really need to go around the buoy again? But it's through prodding and keeping on going and going, hey look, I've got an idea, and I'll do the same thing here, and I'll say, I've got an idea, mate, let's see how we can, and by prototyping it, working out whether it's going to cause a problem to the health of the occupants on the inside, we can make details as close as possible to what everyone's learning, because although it would be great to be able to move on to some really new technologies, but I guess I'll draw your attention back to, well, my dad started working out at BHP, or sorry, on the railways in steam engines. That didn't finish. We're still driving steam engines around properly on the railways until the early 1970s, and now we've got really super fast trains. So there was the workforce there that still dealt with the train engines. We couldn't just merely move to diesel. We had to retrain a lot of people. So we still have to make sure that we work with the trades we've got until a bunch of those guys are ready and moving on to be able to use a ladder system. Then that becomes much more cost effective as well. By example of just using really simple systems, we've been able to use high density polypropylene as a thermal brake because it worked, or hardwood because it worked. Sometimes the solution isn't sexy, it just is modelled for cost effectiveness. And then I talk with Ibrahim and the other builders we work with, which we also train 50% of the passive house tradespeople, because I don't want a carpenter to be doing really fancy wrap details, because it's easy to draw a line around a rafter tail, but then you've got the apprentice trying to wrap a Christmas present, and guys aren't very good at wrapping Christmas presents, and it would be great if there was so many more girl chippies out there and people to do it, but I want a carpenter to do carpentry, and then I want the wrap detail really easy, and that's how we make Passive House really cost effective, and that's how, through the virtual prototyping and getting that stuff right on paper, which is exactly what Alina was saying too, we can really make a big difference.